Hey everybody, day 17 of the Advent of Cyber 2022. Are you ready to get into it? I am. Let's pop over to the box and see what we got going on for today. All right, we got some more secure coding, it looks like. Filtering for order amidst the chaos. Let's go ahead and hit start machine and let that start up while we're reading and finding out what we're doing today. All right, the last couple of days we've been doing secure coding. We've checked in on Santa's application. We've checked in to make sure that the code is secure and the application is running. And now it looks like we're going to do another day of secure coding. Let's check out what it is. After handling unrestricted files, uploads, and SQL injection vulnerabilities, McSkidy continued to review Santa's web applications. She stumbled upon user-submitted inputs that are unrecognizable, and some are even bordering on malicious. Ooh. She then discovered that Santa's team hadn't updated the web applications in a long time. That happens to all of us, doesn't it? As they clearly needed more controls to filter misuse, can you help McSkidy research and learn some useful techniques to handle that in the future? All right, let's jump in and find out what it is that we're going to be doing. Sounds like we're going to continue trying to make sure that Santa's applications are secure. Introduction. At this point, we're already well aware of the security concerns regarding the input validations. Analogist, I have no idea how to say that word. To begin, the castle wall of your application that forms the first line of defense against an array of scenarios from harmless misuse to outright malicious intents. Validating input merits the same effort as the medieval counterpart in terms of its hardening. It goes without question that insufficient effort in the space may result in an attack vector being vulnerable and consequently exploiting your application. On day 15, we talked about input validation in light of unrestricted file upload, while day 16, we focused on SQL injection. So on day 15, we did talk about being able to upload any and every type of file, and if we allow that, then that allows an executable file where you can get a web shell or some type of shell on the back end and therefore attack that server and then pivot off of it. In day 16, we did talk about SQL injection, and we talked about using those injections to be able to go in and deface or change things on the website. In this task, we will be exploring input validation in a more general sense before touching upon one of the most complex use cases, free-form text fields, followed by a quick discussion on how you may move forward in your secure coded journey beyond input validation. All right, input validation foundations. Generally, an effective way to validate input is first to know how a specific piece of data is going to be processed by the rest of your application. That makes sense. In day 15 tasks, Day 15 task is a beautiful example of how, or shows more than or less the mindset required to be able to effectively tackle a specific case of unrestricted files, which it did a very good job of that. Data then goes through the syntax and semantic validation checks to ensure that the user profile values and both proper in the syntax, the answer follows the proper context asked by the question, and logical value. The values make sense for the question. Meaning, when you go put something into a user field, you're not putting in numbers and question marks and special values. You're putting in strings, text. All right, going back to day 15, you cannot manually type your CV in the input field. The form asks for a file, so it's simply not what's being asked. Meaning, CV, we figured out CV is a resume. You cannot just upload any file. It should follow a set of very specific rules, the implementation of which was all discussed in the latter parts of the task. Then comes whitelisting, where you can be very specific with what your form would accept, and immediately strip or even drop the ones that don't fit in the predefined allowed categories. So for instance, if we were going to whitelist something in the uploaded file and we said we will only upload files that end in txt, if somebody tried to upload something that ended in .exe, it wouldn't allow it. All right, HTML5 and regex. Oh, regex. Regex and I are not friends. HTML5's HTML's built-in features help a lot with validation of user profile or user provided input, minimizing the need to rely on JavaScript for the same object. The input element specifically has an array of very helpful capabilities centered around form validation. Well, that's good. For instance, the input type, which can be set to specifically filter for an email or a URL or even a file, amongst others, promptly checks whether or not the user provided input fits the type of data that the form is asking for. And so, feedback on validity is immediately returned to the user as the result. Well, that sounds fantastic. For even more granular control of the input being provided, regular expressions, or regex, can be integrated into the mix. Simply use it in the pattern attribute within the input element, and you're all set. Here, that's a link to something, is a nice resource to get started with regular expressions. A couple of examples are shown below. So let's hover over this and see where this leads to. This leads to regularexpressions.info quick start. So it's going to read you to a regular expressions website, which probably a good resource to go check out. I know I will need to. Okay, so here are a couple of examples. So we got input type is text. The ID is uname. The name is uname. And the pattern, and then we have a regular expression. Now I can read this. So the regular expression means anything that's in a lowercase A to Z, anything that's in an uppercase A to Z, and anything encompassing 0 to 9. And then additionally, this is the same thing. We got email, and basically this pattern is saying anything prior to @TryHackme.com. So basically, it will only allow anything with the domain of TryHackme.com. Makes sense. That way, you're only allowing somebody, if somebody were to go to this site and try to log in with @gmail.com, it wouldn't validate. The pattern in the first line of code is easily one of the most foundational regular expression patterns one can use. The instruction here is to match any string specifically composed of only letters and numbers in alphanumeric pattern that is case sensitive. The pattern in the second line of code above is a bit more pointed in its instructions. We got flashing lights. And it's a bit more pointed in its instructions, specifically that an email can have any characters at the beginning as long as it ends with TryHackme. So you see that where it's got the dot plus, so it's basically saying anything before @TryHackme, and then you've got the breakaway for the .com. Developing regular expressions can be very daunting as its nature is complex. However, its capability to match very specific patterns is what makes it special. Well-built regular expressions introduce a great way to immediately filter out user-provided input that does not fit the specific requirements that you have set. Great. All right, regular expression 101, aka a class for BSEC. All right. In this section, we will talk about some regular expression tips to get you started. To match any lowercase character in the English alphabet, the regular expression pattern is bracket, lowercase a, -z, bracket. We can deconstruct it as follows. The square brackets indicate that you are trying to match one character, one character, within the set of characters inside of them. For example, if we're trying to match any vowel of the English alphabet, we can construct a regex as follows: A, E, I, O, and U within that. Makes sense. The order of the characters does not matter, and it will match the same. Square brackets can also accept a range of characters by adding a hyphen, as seen in the original example. You can also mix and match sets of characters within the brackets. So you see bracket, and then you've got A and Z lowercase, and then A and Z uppercase, means that you want to match any character in the English alphabet regardless of the case, while A to Z lowercase and 0 to 9 means you want to match any lowercase alphanumeric character. Okay. I'm down. We also need to talk about regular expression operators. The simplest one is the wildcard operator denoted by the period. This means regular expression will match any character, and it's quite powerful when used with the operators asterisk and plus, and min and max. The asterisk or star operator is used if you don't care if the preceding token matches anything or not. while the plus operator is used if you want to make sure that it matches at least one time. The curly brackets operator, the curly braces operator, on the other hand, specifies the number of characters you want to match. Let's look at the following example. Okay, that makes sense. Oh, this room is making sense to me, people. Oh, this is amazing. I might come out of this actually learning something. Okay, if we want to ensure that the first part... Let's start with to match a string that is alphanumeric and case sensitive, our pattern would be lowercase a, or let's do this right. Brackets, lowercase a hyphen lowercase z. So A to Z all lowercase, A to Z all uppercase, and 0 to 9 in plus. The plus operator means that we want to match a string and we don't care how long it is, as long as it's composed of letters and numbers regardless of their case. Fantastic. If we want to ensure that the first part of the string is composed of letters and we want it to match regardless if there are numbers thereafter, we would be, we have a caret. All right, we have a caret. So we put caret and then we put A to Z, uppercase, lowercase, plus 0 to 9, so any numbers, and then a star or asterisk and a $sign. We've implemented 2 new characters. What are they? The caret and the $sign operators are called anchors, and they donate the start and the end of the string we want to match, respectively. Since we want to ensure that the start of the string is composed of only letters, adding the caret operator is required. If we want to match just lowercase letters that are in between 3 and 9 characters in length, our pattern would be, start with A to Z lowercase, and it's got to be 3 to 9 characters, and that's it. Got it. Okay. If we want the string that starts with 3 letters followed by any 3 characters, our pattern would be start it with A to Z lowercase or uppercase, 3 in the bracket. Okay, so 3 is min or max. And then the period is donated. That's a wild card. So we got our periods for our wild card. And then 3 more characters and stop. So if we want the string that starts with 3 letters, got it. So the string here has to start with 3 letters, whether they're uppercase or lowercase, and then it can have anything else past that, but only 3 characters. So we could have ABC 1 2 3. Got it. So it's only gonna be 6 characters long, if I'm reading that correctly. There's also the concept of grouping and escaping, donated by the parentheses and the / operators, respectively. Grouping is done to manage the matching of specific parts of regex better, while escaping is used so we can match strings that contain regular expressions. Finally, there's another operator. There's a question mark operator, which is used to donate that the preceding token is optional. Preceding token, so whatever comes before it is optional. Let's look at that. If we want to match both www.tryhackme.com and tryhackme.com, that's without the www, our pattern would be our starting point with our character, or with our caret, so we have our starting point, and we're going to do www / did it tell us what the / was? There's also a concept of grouping. Respectively, grouping one is done. It didn't say what they were. Interesting. Okay. Our pattern would be caret and then parentheses www with a / dot and then close parentheses. So that is saying we're going to start this with possibly www. Maybe. It doesn't necessarily have to be there, but there's got to be something there. and then, or it doesn't necessarily have to be there. www could be there, but if it's not, that's okay. And then we're going to do TryHackme / and it looks like the backslash is kind of an escape out. Yeah, that's what it is. It's an escape out, so you can actually put in the period. So when you put that escape in there, because we donate a period as being an asterisk or being a wildcard, not an asterisk. Let's back up, because we do use asterisks. Since we do donate a period as being a wildcard, we have to tell it that it's not being used as a wildcard. It's actually being used as a character. So putting that backslash in there is basically escaping out and saying, hey, this next thing in here is actually what it should be, .com. So period .com, not being used as a wildcard com. Okay. At least that's my understanding. We're going to continue on. This pattern would avoid matching .tryhackme.com. Yeah. So, okay, we got caret, and then we got www. The caret operator marks the start of the string, followed by the grouping of www, and then we escape the period, and immediately followed by the question mark operator. The grouping allowed the question mark operator to work its magic, matching both strings with or without the www dot. Yeah, see, so we got www. Instead of put www dot, we put www, and then we put that slash in there so we can back out, so we can escape out and make sure that that period is actually part of that. So matching both strings with or without the www at the beginning. So TryHackme /.com with the $ operator. That's what we talked about earlier. The $ operator marks the end of the string. So what we're saying is once you get to .com, you're done. If there's anything past .com, I don't want it. So the $, operator marks the end of the string preceded by the string TryHackme. An escape period and the string .com. We don't escape the period operator. The regex engine will if we don't escape the regex period will think that we want to match any character. Exactly. All right, I think I'm understanding. I might actually be getting this. I never really did understand regex, and I've never really used it. But we're going to see if I'm able to do it today. Let's go ahead and open up a terminal. All right, here's a table to summarize things, so that's great. This will be a great table to mark. So we have the unique case of freeform text. All the techniques we have covered in the task thus far are mainly concerned with structured text, data that we already expected that we should see, like. However, compared to the validation of structured text, free text is more complex and not very straightforward. Structured text or structured data have inherent characteristics that allow us to set them apart quickly. For example, names shouldn't consist of special characters. That's what we talked about earlier. Some names have, but these can be whitelisted, and age should only consist of numbers with absolute maximum number of 3 characters. Well, nobody's going to live to be 1,000, I guess. Syntax and semantic validation checks can be immediately done on them, and the chaos suddenly doesn't seem too bad. That makes a lot of sense. In contrast, free text fields are more a free-for-all, and so validation checks are more limited, and the challenge of securing is generally vaguer. Yet, like all great engineers before us, we power through these challenges and make the best of what we're given. Listed below are some considerations to ponder. First, we start again with the question of how this piece of data is going to be processed by the rest of the application. What will be the context for each freeform field text? Let's see. What will be the context for which this freeform text field will be used? Free text fields for blog posts are tackled very differently than text Fields used for a small commented section or a descriptive text field. Okay. Is this free text field necessary for your business purposes in the first place, or could it be implemented differently while still achieving the same goal? This is essential to know too. As part of writing secure code, it's avoiding writing vulnerable ones. That makes sense. Then we get to the tricky part. All right. Since syntax and semantic checks are pretty much impossible due to the nature of freeform text fields, our best bet in having a bit of control is through whitelisting. The OWASP cheat sheet lists download the general techniques to perform whitelisting, which can be summarized as follows. Ensure no invalid characters are present through proper encoding, and whitelist expected characters in character sets. Best remediated tactic. Let's see. For the next part of the discussion, let's take a look at the simple base code between or below where a programmer attempts to retrieve the usual details from a user. So input validation is name, placeholder, marky mark. Wow, a funky bunch. All right, birthday, January 17th, 1967, email. So we have an email placeholder. We have an age. We have a favorite website, rows, and so forth. Okay, and the example is a bit bare and would have been an immediate nightmare as it raises many alarms, not only in terms of security, but in terms of risky getting a ton of garbage responses. Since all of them are text inputs by default, the birthday age fields may receive responses that aren't within their specific context. Further, malicious users have free reign over the fields, essentially allowing them a free playground to tinker with. That makes sense. So on what they're saying on here is like birthday, these are just text fields. Like we should say, hey, maybe instead of allowing them to type in January 17th, 1967, we only allow numeric. So we would put like 01/17/1967, or make it a date field only, something along those lines. Whereas in here we would say that it has to have an at something.com or dot whatever. Kind of try and block it down. And on the age, we only want numerical values, right? Same thing as the birth date. Let's see what we got down here. In this case, if no input validation is done at all, let's fix it up a bit and review it again. So what do we got in here? Oh yeah, so here you go. Type. So we put input type as text, input type as date, input type as email, type as number, URL. So we're basically saying if it doesn't follow these parameters, then it's not valid. The changes above are literally just additions to the type attribute and their corresponding values within an element. Yet there are already a world of difference between this one and the base implementation prior. Take note that security wasn't the main focus of these changes, yet it exceeds in mainly alleviating the chaos that the prior implementation otherwise invited. Going back to the discussion above, this is an example of the syntax check being done in the HTML layer. So that, I mean, one check is better than no checks, right? All right. The changes above. Oh, here we go. What do we got in here? Oh, here we go. So now we're using regular expressions, or we're using other things within here to say. So now we got, it's a date. The required minimum is 1900, 1900 to, I guess you can't do it if you were born past 2015. And then we're using, it looks like we're using regular expression in here saying anything prior to TryHackme.com, and I guess the name can only be 30 characters, or the field can only be 30 characters long. Hopefully somebody doesn't have a really long name. We're going to put age in here. We're going to say that it has to be Holy smoke, somebody 122 years old. The age could be a minimum of 8 years old, maximum of 122. Then we got a required pattern, so we do see a type of pattern that's in here. That makes sense. I keep saying that makes sense, but it's like it's all coming together for me here. All right, the changes above incorporate both semantic checking and whitelisting techniques to the existing syntax, checking in the prior implementation in order to further filter out allowed values that can be provided in the input fields. All right, number one, the name field, for instance, has been written. Okay, we already went through this. Basically, it's 70 characters. We can see that. I'm not going to go through all of that. These semantic checks should follow the proper business context to be effective. For example, the implementation above is geared towards the TryHackme staff, marked by the email field, only accepting TryHackme emails. Therefore, applying the foundations of input validation not only ensures that the data being provided is proper, but is also drastically limited. It also drastically limits the attack surface in the input fields, especially those requiring structured data. Okay, this is the reason why we haven't touched on text field, the text field tag. Touch on the text field at the very end of the code block. As discussed earlier, freeform text is unique in such a way that applying syntax and semantic checks are pretty much impossible. In order to secure this one, we first need to define what context, i.e. e.g. Characters, character sets, symbols, what is actually going to go into here, and what is going to be accepted, and then perform the actual whitelisting. Even then, even once we do all of that, it wouldn't be enough. Can you tell me why it wouldn't be enough? Think about why it wouldn't be enough. Even though we're going to whitelist stuff, why wouldn't it be enough? Put that thought in your head. It wouldn't be enough, and it's still a very open field. And so techniques such as output escaping and using parameterized queries, among others, should be implemented as well. Client side versus server side. This is one I like to talk about with people. People don't understand the client side and the server side. They just see a website. All right. Our discussion until this point has been geared towards using input validation to ensure that the pieces of data that we're getting from the users are not garbage. Proper input validation on the client side limits misuse and minimizes the attack surface of the application. However, it doesn't actively cover malicious use cases. As opposed to the above examples of validating input implementation on the client side, output escaping and using parameterized queries and implementing on the server side, adding computational load to the server, but ultimately helping in securing the application as a whole. This is done as an exercise of inherent distrust in the user-provided input despite validation. Okay, so what we're saying here is what we've talked about over the last couple of days. You don't trust the person on the other end to put the correct stuff in. Just because it's a name field doesn't mean they're going to put the name in. So you have to do everything you can to lock them in to putting in a name, number one. But what they're saying here is doing that and making sure that they put just the name in by going up here and putting all the validations in on here. It's going to make the server side or the back end use more CPU, use more computer power, because that computer has to think about it. If it didn't have to think about it, it would just let it fly through. But if you just let it fly through, guess what? No security. All right, let's scroll back down. As opposed to the above examples of validating implementation, yeah, we already went through that. The example below uses the built-in HTML entities PHP function to escape any character that can affect the application. So we got a variable of name. We've got is going to equal HTML entities. Get that name in entity quotes, int quotes, and HTML UTF-8. I'm not a coder. I can read it out loud. I don't know what that means. On the other hand, the one below uses the HTML purifier library to help with some cases, such as text area. All right, the conundrum above. So we see in this code, we see PHP require once path to HTML purifier .auto HP. So that's going to be their library that they're using. We're going to configure. It looks like we got configuration, HTML purifier config, create default. Again, not a coder. I won't even play like I understand what that means. Both examples are done on the server side to escape characters and purify context. Respectively, both effective ways to prevent user misuse and cross-site scripting attacks. Implementing both client and server-side validations ensures that no stones are left unturned. So now we're doing it on the front end. When somebody's typing it in, we're making sure that validation is there, and then when that validation happens and comes through, we're revalidating it on the server side. You can't be too secure. This exact case highlights the importance of layering defenses and shows point blank the limitation of client-side input validations. It also gives rise to the notation that input validation is not a one-stop shop for securing your applications. Just like I said, just because you make sure that they input and validate, or you validate that the name field is a name, doesn't mean you don't need to purify it like they're saying here when it hits that server side. Specific cases warrant specific security requirements, and so on this factor alone, it's already apparent that there exist multiple ways of attacking the challenge of securing user-provided input, and most of the time they are implemented on top of each other. Layered security. Not all solutions are equal. Input validation is an important layer of security that all production level applications should have. However, no matter how perfect your input validation is for a specific use case, there simply are limitations to all kinds of security implementations, and input validation is not exempt from it. You can make your applications fully cross-site script proof through input validation alone. Oh, whoa. Let me reread that. I said that wrong. I said you can. You cannot make your application fully cross-site scripting proof through input validation alone. Controls may be put in place at the input level and that lessen the attack surface of the application, but it doesn't fully remediate it. Full remediation of cross-site scripting vulnerability in your application requires additional layers of defenses, such as mitigation on the browser level via secure cookies, content security policy headers, big one, CSP, huge, and etc., and escaping and purifying user input, or making sure that user input is valid. In light all of these remediation techniques, it makes sense to tackle each one on its own. SQL and LDAP related vulnerabilities are addressed differently from cross-site scripting, so why try to fit them all in the same formula? Exactly. Don't try to do it all at once. Tackle everything individually. That's what I say. Always tackle one problem at a time. You know how you put a fire out? A little bit at a time. You don't just throw water and it all goes out. I need some water. All right, so in summary, despite being a very important security protocol, networking right there, protocol. Despite being a very important security control, due diligence in security applications involving user-provided input should not stop at validating the input per se. As seen in previous examples, user input may be valid, but it doesn't necessarily mean it's harmless. There are a lot of tools and frameworks out there that when used properly can secure your application. For instance, HTML5's features can help. They can help in minimizing input form misuse, while the use of regular expressions can help filter out what we need from the user more granularly. We took a closer look at regular expressions, or regex, here, especially because of its powerful capability of implementing filters, which we learned. And while the above examples aren't directly concerned about application security, they help minimize the attack surface of the application, which is further tackled through server-side validation techniques such as output escaping and using parameterized queries. Let's scroll up. Ooh. We should be realistic and not try to solve all security problems with input validation. There is not one control that could prevent persistent malicious actors, and so layering these controls is the better way to move forward. Always, 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 always. Okay. It looks like our task for today is going to be learning or practicing regular expression. So let's jump into it. Our exercise today, we have prepared a regular expression exercise that you can access through the machine provided. First, let's start the virtual machines. Already started. The machine will start. The split screen, we got that. Okay, practice a regular expression first. Change your working directory to the regex practice folder using the using the command. Well, let's just copy and paste. Hold on. ls. Probably faster. Not LSA. Come on, man. ls cd desktop reg. Oh, come on. All right. Got it. So now we're in the folder. ls. And it looks like we got a couple of files in here. Strings. Okay. Then you may use either egrep via the following syntax, okay, or the regex py script written for you in Python. We won't use the Python. We'll just use egrep. Egrep's easy. We are aware that some structured data is more complex than others. So we have set a specific syntax for you to follow to make this exercise a little easier. Have some fun. Okay, filtering usernames, alphanumeric, minimum of 6 to 12 characters, may consist of upper and lowercase. Okay, so our regular expression that we had earlier was on all of the, well, let me make this bigger. On all of these, we're going to start with egrep. So no matter what, we've got egrep. Okay. And we need to start. So remember, we had a caret to start this off. So caret. Oh, caret. Egrep space caret. And then... oh, we need to put... up here, we need to put these in single quote. Okay. Okay, so our first one is filter for usernames that are alphanumeric of 6 characters, maximum of 12. They may consist of upper or lowercase. Alphanumeric. Okay. What did we do? We got the brackets. And we got lowercase a and lowercase z. And then we got uppercase a, uppercase z. And then we got 0 through 9. And then, oh, wrong one. And then we've got, do we need to put this in 6 to 12? 6 to 12. Let's check. I'm going to make sure I'm doing this right. Like I said before, regular expression, not one of my big ones. So it does say minimum of 6, maximum of 12. All right. And then we want to end it. And then we need to put this around, and we need to put strings. Right, strings, yeah. Oh, look at that. Okay, awesome. So I got a regular, I wrote a regular expression, people. I wrote a regular expression, and it worked. Holy smokes. I feel so freaking smart. All right, let's scroll this down. When you learn something new, it's always good. All right, filtering for usernames. How many usernames fit the syntax above? 1, 2, 3, 4, 5, 6, 7. I got 8. 8. Yes? Yes or no? Let's check out what the hint was. All right. What in the world just happened? Whoa! Holy smokes! We got a raid! Welcome in, raiders! Sniffer Labs! Raiding with a party of 8. We are finishing up the advent of cyber. We've 2022 day 17. All right, we're going to filter for our usernames. One user consists of a readable word concentrated or with a number. What is it? And it looks like our username is user35. So we got user35. Let's check that one out. Filtering for emails. How many emails fit the syntax above? All right. Now we got to figure out our syntax for emails. So filtering the emails follows this form. We got local part at domain without the quotations. Local part is a random string, and the domain is in the form of domain.tld, topleveldomains.com. Okay. So let's check that out. Let's see if we can write a regular expression to come up with that one. We got 35. So once again, we've got our egrep. And what are we going to put in for this expression? We've got follows the form, local, okay, without equation. We don't have any specific numbers or letters prior to it, so we're going to go in and put anything. Let's back this up. So we're going to start and we're going to do, remember we had a wildcard and our wildcard is a period, so anything. And then we want to do what at, local part is a random string and the domain is in the form of domain name.top. But it doesn't say how many. All right, so we're going to do as many characters, and then we're going to we're going to have to do backslash, I believe, at some point, right? Let's scroll back up here and make sure we've got everything. Let's look at all of our plus quantifier matches the preceding token one or more times. Okay, so we want to do that plus Let's do. Gotta give that a shout out. Plus, but we're gonna need to escape out. Whoop. We need to escape out of that and put .com. So right now we've got anything. We've got anything plus those many times, but it's got to end in .com. Let's see what happens. It looks like that worked. So start. We're going to start here, anything. And we're going to match it as many times as possible. Doesn't matter. We're not putting a number on it. Right? Plus quantifier matches the preceding token as many times, one or more times. So the preceding token, so as many times. But then we want to make sure that we've got .com in there. Okay. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We got 13. All right, filter how many emails in the syntax. Is 13 right? 13 is not right, so our syntax is wrong. All right, hint. What's our hint? Regex, you may use a wildcard followed by plus to match random strings. In order to match a dot, okay, well, we did that. So, oh, we got a sample. Sample.com. That's not gonna work. We need to put an @ sign in there. So let's do this. I think I missed that. I think we need to put plus, and then we put an @ sign right here. Now if we put an @ sign right there and then we run it, what do we get? Oh, that doesn't work. So anything plus plus add, and then can we put another period? Another period. And match it as many times as possible. That's got to be it. Let's see. Those are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11? Yeah, all right. Oh man. I feel like the king.
I'm the king of the world!
All right, filtering for emails. How many unique domains are there? So how many unique domains? We got 1, 2, 3, 4, 5, 6, 7. Looks like 8. Filtering for emails. What is the domain of the email with the local part Lewisham44? That's AMG. AMG.com. All right. Filtering for emails. What is domain of the email with the local part MaxiMax? MaxiMax. Fedful.com. Fedful.com. Man, we're flying through now. All right, what is filtering for emails? What is the local part of the email with the domain of Hotmail? What? Hotmail.com. Let's see. Is there only one Hotmail? Yeah, there is. Hussein Volt. All right. Filter. Oh, now we switch to URLs. All right. What are our URLs? Filtering for URLs starts with either HTTP or HTTPS. Some of the URLs have www and TLD. Should not. Okay, so we're gonna use egrep again. We're gonna start because it takes too long to. So we got egrep. Put this in. We got a caret. So we're gonna start there. What was it that we do to maybe answer www? We're gonna group. Okay, we're gonna group www, kick out and do that, and then here that right there should say it could be www dot, but it doesn't have to be www dot. Okay, so we got that. Oh wait, you know what? It's not gonna start with that though, is it? It's going to start with HTTP, and it may have S or may not, and then it's going to have HTTP P or PS, and then you're going to have colon backslash backslash, you're going to have 3. So then you're going to have a 3. So there's going to be 3 characters. Oh wait. We need to do a period, right? Because it's going to be 3 characters, which, and then it's going to be possibly www dot, and then does it give us a, no, and then we could say period, is that right? Period, and then we can do it however many times. www dot let me see if we get this right. Period, and then however many times, then we're gonna do the plus. After that we do plus, and that should be anything. Plus, we're gonna end it. Let's see what we end up with. Oh, type it in the wrong place. So we should do here, we should do plus, kill the string off. Let's see what we end up with. I think we're gonna have to clean this up. No, we got something. Filtering for URLs. How many URLs in the syntax? 1, 2. That's not a URL. So that's not going to be right. And a TLD should exist. That's not going to be right. Okay. Hit the up arrow key. Let's check this out again. www. So let's do this. Let's say it's got to be www. Let's take this outside of here. It could be www. We've got starts with that HTTPS period, and it could be www. We got plus. Let me look at that. I've got a cheat sheet over here. I'm looking to see what I've got. So I've got www plus, and then we're saying we're doing www question mark anything, and then we're gonna kill it off. Anything after that plus. And that would say start with HTTP or HTTPS. Could be either one. Then then anything, and anything needs to match 3 characters. And then it could be www. Doesn't have to be. And it could match. Then we're saying any characters. Match as many as possible. Dot. And then any characters. Let's see what we get. We get nothing. egrep HTTP. Okay, let's look at this again. We got HTTPS. We got HTTPS, and then we got 3. I'm missing something. HTTPS. There, 3 www question mark. So possibly with a period, and then anything. I've got that. Then dot, right? And then and then anything after that. Because we closed that out. Okay, this might be it. There we go. That's what I missed. I put a period. I remember we canceled out of that to actually get the period in there, but we didn't put anything after it. So now looks like we've got all of these are actual things. So filtering how many URLs fit that syntax. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Yay! Hey, what just happened? No! OMG! Did it save it all? Ooh. All right. Not sure what happened there. All right, 16. Come on, 16, 1, 6. There we go. Submit. Correct. All right. Filtering URLs. How many start with HTTPS? We go 1, 2, 3, 4, 5, 6, 7. 7? Is that correct? Yeah! All right, we finished day 17. 17 days in a row. These last 2 days have kicked my butt. I am not a regular expression person at all, nor am I a coder. So I definitely need to brush up on regular expressions and secure coding. Hey, we all have stuff we've got to brush up on, right? So for the rest of, looks like for the rest of it, we got, went ahead and cracked. All right, so that's going to end day 17 of the Advent of Cyber. Got a nice little raid from Sniffer Labs. Thank you for the raid. That was amazing. We are going to go ahead and let me see if we've got somewhere we can go. We got some people in here. That is going to end the 17th day of the Advent of Cyber 2022. Thank you all for hanging out with me, watching me stumble through regular expressions, just like I stumbled through last night with our secure coding. Maybe tomorrow it will be more in my wheelhouse and not on the coding side. We'll have to see. But until then, I will see you guys next time.